All they want is ratings. They want fans and butts and seats. They won't care. I'm just doing what the rest of my competitors are doing, even if it's illegal. It nonetheless creates an era with a bubble of home run accomplishments that is unique in the history of baseball. And a part, I think, of being a baseball historian or just a person who talks about the sport is recognizing that this era was unique. The only 6 times that anyone hit over 62 home runs just happened to be in those 4 years. And so when we talk about baseball history and when we talk about records, I think it's fine if one way that we talk about that record, the record of single season home runs, is to acknowledge this historical aberration created, by the way, by this brief introduction of drugs that violated federal law.
Well,
and so
you could say,
so we can say, and I think we should say, who is the person who hit more home runs than anyone else in baseball history? The answer is simple. There's no dispute. It's 73, Barry Bonds, 2001, period. That's the answer to the trivia question. But this is the English language. These are records. We can just make them up. We can make up new categories. And if I think reasonable people can say, here's a new category that recognizes the existence and historical uniqueness of the steroids era, it's called, I don't know, the clean single season home run record. And you
we
can
don't
say
know if it's clean. What if Judge fails a test like next week? Who
if
knows?
he fails the test next week, then he doesn't keep it. But for now, he hasn't failed any tests.
But what if somebody
don't have a
failed a test
problem
who
with
wasn't clean? That's the problem. And how do we know how long the steroids era was? As I mentioned before, like I think people think it was just late 90s, early 2000s. I don't think it was. I think it was way longer than that. And I just think for whatever reason, everything crested in this short window. But like, Mike Stanton hit 59 homers a couple years ago, or Giancarlo Stanton. I guess I still call Mike because I remember when I got his baseball card when he was Mike. Yeah, I don't know. Like, I mean, so much of this, I've talked about this before, but
Recording in progress.
Thank you, Francis. Thank you. So Francis, it's in a perfect position right now where I can see his laptop right there. So that's what we have to have for test 1. Being able to see your laptop. And how do you accomplish that? With your phone, because your phone has a camera. Every phone has a very advanced camera that you can actually place facing at your monitor. So let me go right now and take a copy at once. Let me see. I'll just mimic Francis right there. I'll grab this and just send it to you guys. So one camera could be looking at your face because it's coming out of the laptop. It's the one I'm looking at right now. But the other camera is the way Francis just positioned that camera. Let me go right now, and that's for the exam. Let me see. There, I'll post Francis' picture right there. There. Let me see. Folder 1. There. As. Francis. Laptop. Right there. So I will post it right away. So let me see. There. Can you try to play with your phone and accomplish mimic Francis? And I'll go and post it.
I'm trying to join on my phone, but it says you need to accept it.
Of course, I'll go and accept you at once. Yes. Let me go there. You see. At middle. Thank you. And let me run right away to post Francis' laptop. Yeah. Right there. And I'll post it under announcements, but I'll also put it under proctoring setup. Let me see. There. At middle. Us. There. So you also have the option to come and take it in person at the same time that students are taking it. You can come to my office and take it outside my office if you want to take the exam in person. But email me so I have enough copies to be able to take it in person for the students that are in Austin or thinking that you can do that right there. It will be a pleasure. Let me see. There, Alex also. Thank you, Alex. Perfect. There, I just pinned Alex. Judy. Look. Milani. Let me see. There. There. And I'm going to admit more students. Let me see. There. Let me check. I'm just checking attendance. Yeah, there. Thank you, Darren. See. There. Let me admit Austin. Hola. On Ansley. Right there. Drew, can you turn on your camera? Thank you, Drew. Thank you. On there. And let me just run right away. I'm admitting Jorge and Brian. You see. Hola. And Brian. Perfect. And then at once there. Us. Okay, and let me take it to our notes and let me anybody has a question how the phone has to point at the monitor in your laptop, so I make sure that you are not just browsing an answer or something like that, just to make sure that yeah. Questions? Thank you, Hope. Right there. And let me check Zachary. Thank you, Zachary. And thank you, Kerry. Right there. So Kerry is mimicking perfectly right there. So let me get Kerry and I'll copy and paste Kerry to there. Also, we have Francis, but Kerry position the phone there. Perfect. There. Thank you, Kerry. Can I use you as a model? Thank you. I have to ask permission. Yes. Thank you. So perfect. Now the exam is next class. So let me go and talk about the sections that they're going to be in the exam. Potentially they're going to cancel class because of the weather, and when they cancel class because of the weather, they cancel even DLS. So then I don't have power over that right there. If the school cancels, the school cancels. Period. So let me go right away and share with you. Thank you. I will put Kerry as a model. So make sure that you can mimic Kerry on the technology with your phone. Let me go and share with you right there, and just go to the topics of test 1 right there. If they cancel class, everything will be moved by Tuesday next week in the event the school cancels. So we will get that. Let me see. I'll go to our notes right there, and this will be let me see. This was math 1342. So there's us, and is lecture 1, week 5, Math 2305. And then those are the topics. All the way to section 3.3, which is the multiple quantifiers. So let me see from here. There from chapter 1, we have the universal statements. Existential. Statements. But they repeat because we see them again in section 3.1, 3.2, 3.3, and conditional statements, universal conditionals. In chapter 1, you saw they show up to break the ice. Chapter 1 didn't used to exist in the textbook. So these ideas map to they map to chapter 1, but they also map to section 3.1, 3.2, and 3.3 right there. They're in both. We just see those twice. Less notation for chapter 1 and more symbolic for chapter 3. Let me see. From chapter 1, we also have a relation. A relation, R, is a mapping from a set X called the domain to a set Y, the codomain. Codomain right there. And then let me check. There. Example. Right there. Well, this one that I did right here. That set, the set with universal statements, existential statements, and universal conditional statements. So the set X has existential, it has universal. Let me admit, Jose. Has universal and universal conditional. So it's a set with 3 types of element right there. And that maps as a relation to Y. And Y is the chapters that contains those ideas right there, the section. So chapter 1. And of course, let me go right away to chapter 1. And chapter 1 is section right there. Let me see. In chapter 1 is section 1.1. Section 1.1. Right there. And then of course they also map to section 3.1.3.2. Yeah, right here, section 3.2. There. So universal conditional maps there and maps right there. So it's definitely not a function right there. It's not a function. It maps to those. And of course, the universal section 3.1 and section 3.3. Right there, we can see existential mapping to section 3.1. Existential mapping to section 1.1. Perfect. And universal mapping to section 1.1. And mapping to section 3.1. Right there. So perfect. So these are order pairs. At the end, what do I see on this relation? Order pairs. The relation R is a set. And then the first element of this set is going to be existential mapping to section 1.1. So existential statement, comma, section 1.1. Comma, and so on. Right there. How many elements is going to have this relation? Can somebody count for me how many elements?
It's 6.
Let me check. Yeah, 1, 2, 3, 4, 5, 6. Yes. The size of this set is 6. Right there. Perfect. That's it. So, a relation. Every function is a relation. If f is a function, comma, then f is a relation. But not the other way around. Right there. So that's true. What this is a true statement. Every function is a relation. Is a true statement. Right there. But if you write, if R is a relation, comma, then R is a function, that's a false statement. There, let me circle there, that. So that's false. Let me see. I'll say it. That's false. How do you prove a conditional statement is false? This is very important. How do we show a conditional statement. Only a conditional statement. Is false. You show that a conditional statement is false to prove falsehood with an example. It's called a counterexample. That's the only time we're going to be using examples in this class. All the other ones are going to be proof, formal proofs, but we use an example to prove the falsehood of a conditional statement or a universal statement. If you can write, if the universal statement can be written as a conditional statement, then you can prove falsehood of that universal statement. For example, if somebody gives you a conditional statement, meaning a universal statement, let me see there. I'll write this one as a universal, but it's more informative to have it as a conditional. But I'll write it as a universal. Or can somebody tell me how can I write that conditional as a universal?
For all relations R is a function? No.
But yes, all relations are functions. Yes. But it's a lot more informative to have it as a conditional. We love conditionals. It's not that we dislike universal statements, but perfect. These two are the same. All relations are functions. Right there. So we've written that one as a universal. And we know it's false. Perfect. And then you provide a counterexample. So that's what I'm going to ask you really fast. I'm going to make a fake immediate to make sure that you can upload right there. Okay. I'm going to make a fake assignment right away in Gradescope to make sure that you can write on a piece of paper, take a picture with your phone, and upload it to Gradescope, because that's going to be during the test right there. So what I'm going to ask you is construct your favorite relation. Just make up your favorite relation right there and construct a counterexample to this right there on 2 separate pages. So then, of course, right away, I'm going to create right now an MS Word file right here. So here it's an old Calc 3 test. No, old today Calc 3 test. So let me see. I'll just there. I'll open it from above. Oh no, but I wanted the name. I wanted the name, and I'll change the problem 1 and problem 2. So then I'll go to that file and create now 2318 right there, and that's going to have a question. You potentially can print this and work on this if you want to right there, and then upload this. So here it's a fake activity. Here construct your favorite relation right there. Perfect. And on the next one, this problem 1, Control C, problem 2. Let me keep going down right there. Control V, and there I put problem 2 right there. Problem 2 is counterexample. Construct a counterexample. Show the conditional below. The conditional statement below is false. There. And how do you show falsehood? Construct a counterexample. And here it says, if R is a relation, comma, then R is a function. Okay. Perfect. So let me save this. And make a PDF and run to MS Word. And then as you are working on this, I'll create that that pseudo assignment. Let me see, and this will be test 1 mock upload. One thing that is very important, as soon as you upload, please email me, because I need to check that the upload went through. If the upload didn't go through and then we leave the test and everything, I don't have your test. And then the test becomes a take-home test, and I have to give you a 0 for the test. So I need to check that the upload is legit, that I can read it, that I can grade it right there. So please, during the test, when you're done, tell me I'm done and I just uploaded the document. So then I'll go and check if I can just grade it, if I understand the handwriting, if I can follow it right there. So right away, let me see. I'll save this, then I'll make a PDF, and I'll run to Gradescope at once. There. So there are 2 problems, and you work them on that page. Try not to bleed to the next page. It's 1 problem per page. Right there. So let me see. I'll go and make up. I'll make up this really fast. So I'll need to stop sharing in the event. I'm nervous that some grades are going to show up. I cannot show up grades, share grades on the Zoom. There. When I was in elementary school, they used to just call our grades out loud right there, which I find that to be just, incredible that we did that in Argentina. I'm not sure in the US. I think the US at that time, they did it too. So let me see. There, I'll run to us. And I stopped sharing because I'm terrified that if I open Gradescope, the grade book could show up. It will not, but just there. Let me see. And then right here, I'll create a pseudo mock test. Admit. New assignment. Well, okay, I can share. Nothing is gonna show up. Right, let me see. There. A new assignment that is linked. It's an exam. Next, I'll upload the PDF. And the PDF is around here. Mock test 1. Test 1 mock. And then I'll call it test 1 mock. Fake. practice, upload. And then I already have, oh, sorry, I already have the PDF there. It's going to be uploaded by you. Release today, right now. 18, 2, at 6 p.m. And then due date 8. 8. There. Oh, sorry. I go back and click on it. 18th. The 18th at 8 p.m. There. What else? Fixed length. Create. So let me stop sharing. And then let me go back. So let me see. I just created that mock upload for us to practice. There. And then I will attach the PDF edit to the front of the assignment. So in the event that you want to download the PDF and work on the PDF, I'll do it at once. There. Perfect. So that's it. Let me share with you at once. So there. Let me see there. There. Right there. So you can click on that one and upload. So I'm waiting for your response right there. 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 Yes. Let me stop sharing for a second.
How will we do this during the test if the phone that we use to scan the PDF is the phone that's filming us?
Oh, but yeah, you are going to have to disconnect for 4 minutes. I can still see your face, but from the laptop, but I will not, you will be using your phone at that moment. But you tell me, I need to use my phone because I'm ready to upload. Perfect. And then you can do that. Yes.
Okay, thank you.
My pleasure. see there. There. And let me make sure I am recording this. Yes, I am. So let me check some of the uploads right there. Yeah. So thank you. I have 5 submissions right there. Can you make sure that you are all able to submit? So go to Grayscope, please, and submit the mock test, the fake test. They're just 2 questions. Oh no, oh Kerry, you just put right there a question. If you need extra time on the exam, no problem. I'm not going to rip the exam away from you. So classes ends at 7:20. But if you need more time to finish the exam, you can keep going on the exam. I can stay till 8 o'clock if you need to. Right there. Those are for all students, including the students that have accommodations and need more time. No problem. I'll just stay till you finish the exam. I'm not going to just turn off the Zoom meeting if you haven't finished. Happy with yeah. So you can go leisurely on the exam. You don't need to hurry. I try to make the exam for an hour and 20 minutes, a little bit less, an hour, but you can take longer, no problem. Oh, now that I have more leisure and I'm not sharing with you guys, I can read the comments right there. We know that we have a lot of memorization because you need to memorize how a conditional statement behaves logically in a truth table, how the and, the or, and so on, and then all the definitions. What is a right there, what is the contrapositive, what is the converse, what is the inverse, what is for a statement to be sufficient, a sufficient condition, a necessary condition. So there is a lot of memorization. This class gives me the feeling of statistics, of a stat class, in the way that we are memorizing so much vocabulary. But math, discrete math, has as much vocabulary as an applied statistics course. They're different, but they have lots of vocabulary, more than calculus. It has more vocabulary than algebra. So let me check if you were all able to submit, and then I will continue. Let me see. Right there. Let me see. And let me go through the attendance right there. Let me see. There. Ansley, were you able to upload?
Sorry, I was having technical difficulties. I will not be in this situation on the actual exam yet.
Let me see. Yeah, and let me see there. So yeah, try to see if you can upload. And let me check. Drew, were you able to upload? Let me check. Brendan, let me see, Brian. Drew, I don't have you. Oh, I can't hear you. Let me see.
It says in the grade scope that my thing has been submitted.
Oh, let me check out once. Yeah. And let me check. And Ansley, were you able to fix your problem?
Let me see.
Thank you, Drew. Nathan, Mervin, Melanie. Perfect. Let me see. I have 22 total right there. And let me check the roster of the class. There. Let me see. Yeah, there.
Okay, mine should be uploaded now.
Okay, thank you. Let me see. Thank you. Let me go and check. There. Oh, Brandon, when you're able to upload, Brandon.
Yeah, I uploaded it a while ago. Is it not there?
Oh, because it's telling me that it's not there, but let me check right away. And I say Brandon, no Brandon.
Yeah,
That
it's all
is on
good.
the
I'm
same-
used to it.
I'm uploading it right now.
Oh, okay,
First, my
perfect.
bad.
Yeah, no, I see you, Brendan. Right there, yeah. But Brandon, I didn't have you. Yeah. Let me see. There. And let me go and check Ansley at once. There. Okay, perfect. I got you, Ansley. And then Gunwo and Brandon. Perfect. And let me check. So then I have 7 students. Jorge, you were here. Jorge. Let me check at once.
I'm doing it right now. Sorry.
Gracias, Jorge. And let me check there. There. Perfect. There. Because then I have to send emails to the students that didn't. Oh, Hope. I don't have you, Hope. Let me check. There. Hope was here. Let me see. Okay, there. So let me go right away and continue at once. I'll go and share with you right there. And let me see. I'll stop sharing for a second. There. I'll move things around. And then I'll share with you. And I'll go back to OneNote. So thank you for putting those two questions right there. And then next, let me make sure that you can, I'll share right now. There. So one note. So the other thing right here is talking about sets. The set notation. A 1, 2, 3, right there. So there I'm looking at also at chapter 1. Chapter 1, the language of sets, section 1.2, break the ice. Section 1.2. So there, when we look at a set, we say that B is a subset of A, right there. So, for example, 1, 2 is a subset of A, right there. A is a subset of A because the definition is A or B is a subset of A means if X is an element of B, then X is an element of A, right there. So that's the definition of subset, right there. So there is subset. B being a subset of A. So perfect. Right here, let's take a look at this statement. If empty, if X is an element of empty, comma, then X is an element of A, right there. Is that a true statement or a false statement?
False.
False. Why?
A has 3 elements. It's not empty.
I'm sorry. I was doing this independent of that set, but it's, of course you can connect it if you want to. Doesn't matter. It is the same right there. So perfect. Careful. Let's take a look at the hypothesis. What can you tell me about the hypothesis?
Is it a contradiction?
The hypothesis is always false.
That hypothesis is false. The hypothesis is false. What happens when the hypothesis is false in a conditional statement?
Vacuous truth.
Vacuous truth. So that is true. Don't change your major. Embrace math. Defend math anyhow. Doesn't matter. It's a minor issue right there. But that's a true statement. That is a true statement right there. Okay with that? That is a true statement. So, and look what we're saying is the definition. So, it's saying this. It's saying that those are equivalent. That's the definition of subset. So, yes, the empty set is a subset of every set. The empty set is a subset of every set. because when you write the definition as a conditional statement, you get exactly what Francis said. The hypothesis is false, the entire statement is true vacuously. So it's vacuous truth. And vacuous truth, it is true, is truth. Right there. So when I go and get all the subsets of the set A is there, and I need to write all subsets. So write all subsets. That's also a set. So I have a set A, and in math, many times when they give you a set, then they want to talk about all the possible subsets that you can create with that set. So it's another set made out of sets. It's a set made out of sets. So this set is called all subsets of A. And is, well, all the singletons. All the sets with two elements. All the combinations to give me the set with two elements. So there is some counting going on right here. It reminds me of my probability class. The counting at the beginning of the probability class. 1, 3. And 2, 3. What are the set I'm going to put in that set, in this set? This is a set with sets. The elements are sets themselves in this set. What else am I going to put in that set?
The set 1, 2, 3.
The set 1, 2, 3. I'm going to write it as A itself, right there. And what else? They better be 8, because the formula is 2 to the size of A are the number of subsets of the set A. 2 to the size of A, which is 2 raised to the 3, because it has 3 elements. So it's an 8. I better have 8 elements. Which one I am missing?
The empty set.
The empty, yes, empty. Empty is legit. Right here. So empty is right there. So the name for all subsets of a given set is called the power set. The power set of A is the set with all the subsets. I'm not going to write it again, but I'm going to go like that. It's the same what that is above. Right there. An A, an empty. Right there. And the formula is, if the size of A is n, the size of the power set of A is 2 to the n, right there. And then that can be proven. We will prove that by induction. We will prove that I don't want to call it fact, but people might call it fact. That fact, we will prove that formula by induction later on in the class, right there. So perfect. So we have subsets. Then we have this, for example. Let me put a fence. Notation problems that we've done for homework. Is that an element of that set? Question. Is this true or false?
False.
False. Yes. Yes. The set containing 1 is not an element of that set containing 1 and 2. Right there. This is false. Right there. True will be this. This will be true. Or this will be true. Right there in terms of notation. 1 belongs to the set containing 1 and 2. And the set containing 1 is a subset of the set 1, 2 containing 1 and 2 right there. So the one below, both are true. Right there, let me circle them. Right there, those two are true. They're perfect. Right there. The definition of a function. We went over the definition of a function. Right there, there. F from X to Y, right there. Let me see. There. I'm just trying to think of. Please memorize. P implies Q. Being it is not the case that P happens and Q fails. Right there. Because the negation of P implies Q is P happens and Q fails. Right there. So that is the most common mistake in the exam, that if I ask for the negation of a conditional statement, I always want one student potentially right there could write something like this. And we know that that's not true. Right there. We do not distribute the negation like that over the conditional. That could be a common mistake, that we think that math could be pretty like that, and it's not that pretty. Right there, in that sense. Right there. That's illogical saying that. But sometimes we could potentially say something illogical happens. Okay, so that's not true. Let me see. There, I could give you arguments that you need to potentially any argument. P implies Q. P therefore Q. Or a more complicated argument. I could potentially ask the question where show is valid, show is valid or invalid, show valid or invalid by, and then critical row. That is with the truth table. But show it by truth tree.
On the exam, would we have a choice, or would you be like do truth tree or do critical row through this method?
On one problem you will have a choice. On other problems I will tell you which approach. Right there. And then that's that, or the last one is by conditional statement. There. So by condition, let me put all of them here. We have number 1, number 2, number 3, and number 4 is conditional statement and algebraic moves right there. So it will be conditional statement but not a table, but you just start doing the algebra right there. So let me go here, and algebraic moves. There. So let's take a look at the one with algebraic moves. Potentially you can get stuck, but just try to take it as far as you can. If it's a valid statement, you're going to take it all the way to a tautology. Remember that. You're going to do all the little algebra all the way to a tautology. Let me go and start it right there. But that one is the most treacherous is the last one right there. Because there we're doing algebra and we could get stuck. So that's the one that I will give the most partial credit. That one I give because I know you're a human and I'm a human too. So there you could potentially get stuck on that last one. But it's just, let's just start it right there, right here. So we'll go and write it as a conditional statement. And we'll be able to do it correctly because look what I have with me. I have a book with my favorite mathematician, Amy Noether, right here. So and she's an algebraist. So perfect. So we have everything on our side with her. Okay, with that, okay, I have goosebumps right now. So I'm gonna put her right here, right next to me here. So we'll get it correctly. We'll get it correctly right there. Yeah. So yeah. Okay, right there. So let's see. If I make a mistake, help me right there. But perfect. So yeah, she moved to the States.
Oh, I have a question about that. Do we need to know the name of each rule to cite? No. Okay.
No.
We just need to know what they are.
Yes. So perfect. We come right here and we write it as a conditional statement. The first P implies Q. And I'm sorry, I put P and P. I didn't want to put P and P. Right. Yeah. I see P, therefore Q. Right there. So perfect. The second premise is P. And then all the parentheses, that's the entire hypothesis. And goes to the conclusion right there. We'll be able to do it. But start working on that because look, I'm going to show you something right away. That I was going to show you last 2 weeks ago. But let me see, on the internet, they have truth trees, truth tree generator. It's making a combination of turning into a conditional statement and making a tree on the conditional statement. Right there. Here, the UmSum tree generator, right here. I'm going to click on that one, right there. So here you have that tree generator. So I can try to put the conditional statement right away. What I just wrote was P implies Q. I put a parenthesis. I put an and. I put a Q. I put another parenthesis. I put an implies, and I put a P there. I'm sorry, I put a P there, not a Q. And then I put a Q right here. And check it out. This is, so it's turning that into a, if I click on run, it's going to turn it into a, it's going to try to give me a tree right there and see if that's valid or invalid. That's just like a computer program. If it's invalid, this is a computer program. If it's invalid, is right there. Perfect. It told me that it's valid, and can you see that all the branches cross? Right there. So it's changing both. It's making a mixture of you solve the tree, but by making the not playing with the set and negate the conclusion. Remember that we negated the conclusion. This is not negating the conclusion. So let me bring this to our notes right there. So there, so that's a different way also. There. This could have been a program that I written in Fortran, and it had those operations. And then, of course, it's valid. It's not going to give me fatals at the logic level. It might potentially give me fatals at the way that I wrote other things. But at the computation itself, the way I put the symbols and the computation is valid. So the fatals would have been by something else, but not by the logic of the program. Can you see what I'm saying, where this is used? So let me bring it to our notes right there. So I'll put that in one note, and that was the tree generator. And then right there, perfect. There. But it negated the conclusion. It negated the conclusion right here in the middle of the work. It put a no Q right there. Oh, let me tell you why let me see. It did this. This is the logic for what the program did here. P implies Q. It want to show that that's valid. So it negated the conditional, the entire conditional, the everything. It just, let me just write it out. It negated everything. The entire conditional statement. And it arrived to contradictions here and here. So the originally must be true. So it negated P implies Q, and P it negated the entire conditional statement, and it arrived to a contradiction. So it did it prove by contradiction. Hence, the original must be true, right there. Oh, okay, well, this is slightly cleaner than the trees that we do. This is slightly cleaner. But of course, let's try to mimic that algebraically, and we will arrive to a contradiction right there. Oh, let's just do it the way we always do it, right there. But again, look, if we start the tree, look what it did. It did that, and the next thing is to write what this means. It means this. This is equivalent. This is equivalent to, because it's negating the conditional, it's equivalent to P implies Q, and P and no Q. Right there. Okay with that? That is exactly the orange. They are the same, because remember what you do when you negate a conditional. I'll write it again here. The negation of a conditional is the hypothesis happens and the conclusion fails. That is the negation of any conditional. Now, look at the negation of this conditional. The main operation is that one. So, The hypothesis, it's all of this. And negate the conclusion right there. That is the negation right there of a conditional. The hypothesis is P implies Q and P. And you see them right there. It's an and. And you see them right there on the tree. That one and the one below. Both. And right there. And then, of course, it writes it again because it's another and. Right there. But it's also this P. But then you have the P right there. And then, let me see, there. The not P. The not P, let me write this one. Doesn't want to work. I need to put it right here. I'm going to write that P implies Q as it is not the case that P happens and Q fails. The P implies Q. It is not the case that P happens and Q fails. But it is not the case that P happens and Q fails is the same thing as not P or Q. And you can see the not P or Q below. Can you see that it branched into the not P or Q? Right there. Let me do those moves. Oh, I won't move it. Now I'll grab the pen again. This right here. There. That there is not P or Q. And the not P or Q, you see it right here. Not P or Q. Right there. So, but again, let me go back and take a look at what we were going to do. Just the algebraic moves on this one. I will bring it down and show that it's a tautology. I'm sorry, I kept talking. It's 7:26. No. I need to shut up. It's super freedom. Right there. Total freedom. I'm sorry. I will write it down and print it. But I need to give you your freedom. Right there. Any questions?
I've got a question. On
Yeah.
one of the homeworks when I was doing the truth tree, I came into a statement that was P and Q or R all in one group. How do you deal with that in a truth tree?
Perfect. Right there. Let me see. There. When you were doing all the operations, it had to be the case that there was a parenthesis that you missed somewhere, because it's terrible when this happens, because I see the or and the and in equal stand right there. So a parenthesis was missed somewhere right there. It had to be the case, Brendan. Because I cannot prefer one over the other one and just make an associativity. They're both equally standing right there. So something was going on, or it was this, or it was this. Oh, sorry. You know what I mean. And I cannot pick a favorite between those two. Algebraically, right there. So I'm stumped when that happens, and I need to track all my moves back to what was the mistake.
Understood. Thank you.
My pleasure. So I'll finish what I was going to do, that I started talking about that software that checks for validity, but I'll go and move this down. Let me see. And I'll do it algebraically right there.
I had a question about the conditionals and the all statements, if you said that like all dogs are friendly, if that's the same as an if then statement, if something's a dog, then it's friendly, how do you know which negation to use?
Okay, let me check at once. Perfect. Let me see. Right there. All dogs are friendly. So that's logically equivalent to if dog then friendly, like you just said. And then if we want to negate this, but we're looking at this one. The negation is I have a dog and is not friendly. But that is identical to what we would have done with the conditional statement, because this is P. Can you see that it works, Ansley?
Yeah, it's just like dog but not friendly.
Yes.
Okay.
Yes.
It just
Yeah.
doesn't
P.
sound as nice to say that than
Yeah.
some
Yeah.
dog.
Yes. Yeah. But you would have done it P, dog. And not friendly.
Okay.
Right there. My pleasure. Right there. And then
I'm
I'll put,
wondering, I was
Yes, yes.
also confused while I was studying about only if and if then.
let me see.
In the homework, we had a problem that was like, the team will win the pennant only if they win the next game or something like that.
Perfect. P only if Q is logically equivalent to P only if Q logically equivalent to if not Q then not P. But that is logically equivalent to P implies Q.
I guess I was confused because doesn't that make only if and if then the same?
Yes. They are the same. Yes.
Okay. But if and only if is different.
If and only if is different. Yes. And P if Q is different. P if Q is Q implies P. And P only if Q is equivalent to P implies Q and Q implies P.
Do you mean if and only if?
The if and only if. Yeah. If and only if. I'm sorry. Yes. If and only if. That we always write like this. Right there with the double F.
Okay. For the problems that are like the knights and knaves problem, I saw that you had one on one of the practice tests, but I didn't know. I got really confused about how you wanted it written out. like how to translate it into notation and how to write down the argument.
Oh, okay. Let me take a look at that problem. Do you know which test is it?
I think it's the first one. It says write the answer on the back of the page, and so I think that the answer that you wrote didn't get included in the scan.
Okay. Let me check. I'll run to that problem. Let me see. There. And course documents.
Well, there aren't going to be proofs on this test, right? Just
No.
counter example. Okay.
No proof.
And I'll save all my proof questions for later.
Perfect. Yeah, no proofs. Let me see.
Was that it? No.
The test.
No, sorry.
No more.
Was in the other class sections?
Oh, let me see. I think it must be showing up very soon. Let me see. I hope. Yeah. Test. Maybe I passed. I think I passed. There. There.
We could just do that knights and knaves problem if you want to, instead of pulling the one out.
No problem. Let me see. I'll
Because I
grab
don't really care about which one it is.
there. And I'll send it to our notes. Right there. Perfect. So the anthropologist, Edgar, meets two inhabitants of the island, and one of them, A, made the following statement: both of us are knaves. There. So if it's definitely whoever said that is not a knight right there, because a knight will have to tell the truth always, and the knight cannot potentially tell you that she is a knave. Okay with that, because the knight tell always the truth. So A is definitely a knave. Right there. And what is B?
A knight.
A knight. It gotta be a knight. Can you see that we explain it with sentences right there? So what we say is exactly what I said. A has to be a knave, because no knight will tell you I am a knave.
Okay.
And also, no knave will tell you I am a knave, because the knave will be telling the truth. But again, because this one is both of us, definitely A is a knave and is lying on the end right there, because B is a knight. Okay, okay.
Yeah, so we don't have to write any kind of notation, really.
No.
Okay. Okay.
Okay, any other questions? Jorge, were you able to upload? Jorge. Bueno.
Yeah.
Alex, were you able to upload? Alex.
Yeah.
Gracias. Okay, Super Freedom.
Bye.
Ciao.